All right, for this video, we're going to take a look at piecewise defined functions. We're going to think about two parts here. One, just how do we understand and evaluate a function as a piecewise function? What does that even mean? And then in the second part, we'll take a look at the graph. So for the first part, evaluating a function here, f of 2, f of 3, f of 7, we really need to understand what a piecewise defined function is. And to take a look at this, we'll look here and we see this graph has, or this function has three pieces. And the pieces are defined as a function here paired with a domain. So in this case, the first piece of my graph is just y equals 2x. And that's just going to be the function when the input is between 0 and 2. So first thing I'm going to do for my first input here is just figure out, okay, where is 2 in the domain? And that's going to tell me which piece of the function to use. So because 2 is in that first inequality, I'm going to use the first function here. So 2x, when x is 2, I'm just going to plug in 2 for that function, and that gives me 4 as the output. For the same idea for 3, we're just going to find, all right, which part of the domain, which piece of the domain is that going to fall in? And that's going to tell me which piece of the function to use. So 3 is in the second piece of the domain between 2 and 4. So for this one, I'm going to evaluate using that second piece. So f of 3 is just going to be 4. So the function is just y equals 4. So no matter what the input is there, the output is just 4 again. And for f of 7, that's clearly in the final piece of my graph here. So we're going to use the final piece of the function. So f of 7, we're just going to evaluate using the 1/2 x plus 2. So that's going to be 1/2 times 7 plus 2. And that's going to be 3.5 plus 2 would be 5.5. All right. So that's my part A. We're just identifying which piece of the domain I'm in and just using the corresponding piece of the function to evaluate. When we're making the graph, we're basically thinking about the same idea here. I'm going to look at the domain here, and I went ahead and sketched some boundary lines here. So the idea that I'm trying to get across here, these are not asymptotes. These are just the boundaries between which the different pieces of the graph are going to be created. So this is not a part of the graph that you would need to put on yours. This is just, I'm trying to visualize why I'm stopping the graph where I'm going to be stopping it. So between 0 and 2, I'm going to graph the function 2x. So that's just y equals 2x. So that has a y-intercept at that spot right there. So right there, up to over 1, and then we're just going to go straight up like that. Okay, between 2 and 4, it's just the function y equals 4. So that's just a horizontal line between 2 and 4. So for this, I'm going to start my graph at 4, and it's just going to stay horizontal. It's not a very good horizontal line, but you get the idea. And then finally, we're going to evaluate this function right here. So to understand this one, we need to know where to sketch the graph to start. So I'm just going to sketch the graph at that endpoint. So f of, actually, I shouldn't say f of. I'm just going to do 1/2 times 4 plus 2, just to understand where this graph is going to start. And that's 1/2 times 4 is 2, plus 2 would give me 4. So even though this is an open circle, it's going to connect up with the graph right there. And then from there, that's just a linear equation, up 1 over 2, up 1 over 2, just like that. And we're just going to sketch my graph like that. So that would be my function, piecewise defined.